Welcome back to the second part of the online assembly techniques part 2. Just a quick review. Yesterday we went ahead and went over top-down design. That also covered things like master modeling technique as well, and also in context design, assembly features, things like that, and how you kind of get them to propagate over to your model. And now what we want to focus on are mating techniques. And then we'll talk about Toolbox Components as well, things that you can do to improve large assembly performance, and as well as we'll wrap it up with file references. Okay. And once again, if you guys have any questions, feel free to write it in the message box, the questions. I'll see if I can get back to you as soon as possible. But if not, we'll kind of save it for the end, anything that kind of I wasn't able to address, right? So we'll try to answer the questions as we go along. So here we want to talk about mating techniques and then also introduce new mates. We'll talk about standard mates, quick mate toolbar, Smartmates, and then also introduce the new mates, things like the slot, the profile center mate, and the width mate. And if you've used the width mate before, right, you'll notice that it's not exactly new, but they've introduced things like where you can now, it's always automatically centered, but you can add in free, you can do a dimension as well as a percentage. So let's go ahead and pop back over to my assembly. So you've noticed from yesterday I'm using the Resonant Bolter 77D. And I'm going to go and open up my primary error filter here. And, you know, kind of covering once again the span of assemblies. Mates are what we're going to use to reference one component to another, kind of how we use relations in our sketches. Okay, so how we would add a mate is really simple. You just go up to your mate, and what we'll do is we identify, for example, our standard mates on the left-hand side, things like coincident, parallel, perpendicular, tangent. And then we identify what we want to mate together. So for instance, I want to go ahead and mate this cylinder with this one. And based off of what I select, it's going to try to choose and assume what kind of relation I want to add. In this case, I chose two cylindrical surfaces. It's going to want to go ahead and make it concentric. Press OK. And then what I'll do next is I'll zoom in and I'll grab in that face. If I go ahead and click on the G key, we talked about that yesterday. This creates a magnifying glass, and it just zooms into the portion I want to select. In this case, that face. I'll go ahead and make those tangent. Okay. One small little addition that's been added is the ability to lock rotation. So as you can see right now, on the left-hand side, this component is underdefined. And in most cases, you're okay with having it underdefined, having some kind of degrees of freedom. But if you want to go one extra step and say, I want to be able to fully define this, right, and prevent its rotation, what you can do is on that specific mate, this concentric one, if you edit the feature, there's a checkbox now for lock rotation. So if you click on lock rotation, then press OK, you'll notice that the minus sign goes away. And if I try to left click and rotate this one now, it's now telling me the component is fully defined. It cannot be moved. Okay? So if you've ever wanted to fully define something, in this case, lock its rotation, you can now do that. And you'll notice the icon itself, it's filled in, it's shaded inside. That means it has a lock rotation on. If you want to disable it, you can right click and go to unlock. And then you can notice now what color that is. So it's no longer filled in. That's identifying when you have lock rotation on and when you have it off. So now what I want to do is right-click lock the rotation. And for instance, I could still add a concentric mate between here and here as well. Bring that down, add a distance mate if I needed to. And then now what I want to do is I want to focus on adding in some coincident mates for my axes. So you can see here I have this original component. It's brought in fixed, right? It's the first component I bring in. It's going to be one center at the origin. And this has an axis. So if I go ahead and go to my view, temporary axes, I'm going to turn those on, and then I'm going ahead and mate with respect to that axis. So I can mate using faces, edges, but you can also use axes and planes as well. And it's something about the planes will not disappear from the part, right? So here we have our axes. If I want to go and mate to it, I can go to mate. And on the left-hand side, I'm going to use the multiple mate mode, and I'm going to just left-click this. So how you would activate multiple mate mode is you left-click. And on the left-hand side, here's a common reference. And under common reference, I'm going to select this axis. And then afterwards, I'm going to select the subsequent references. So all I have to do is select this axis. Notice how it lines up, right? And I don't want to press OK because I will finish the mate. I want to go ahead and keep clicking on the other axes that are going to reference that main one, that common one. So I'll keep left clicking. Okay? And what that's going to do is align them all up together based off that common reference, that axis. Now, if I wanted to go ahead and create a multiple mate folder, I can go ahead and click on this. What it'll do is it'll organize into a folder for me. And once I press OK, you'll notice what it's done is it's created a multiple mate folder for me. They're regular coincident mates, so if I wanted to modify them individually, I can do that. And I can always edit the feature as well. And if I wanted to go one step further and then rename this so that the next person seeing this kind of figure out what exactly did they do here, you can say major axis. You can rename it to whatever it is to specify exactly what's going on with that mate. The next thing I want to do is I can hide my axes, turn off my temporary axes. I can also do what we call quick mates. So just going over one more time the multiple mate mode. Someone had asked to show it one more time. So I won't actually do it again, but what I'll do is let me just show you how to activate it. All you need to do is go click on multiple mate mode on the left-hand side. It's just a toggle button. And what you'll do is you'll get a common reference, which will be like my main axis. For example, say it's going to be this one here. And then afterwards, your subsequent references, you'll select the other ones. And then you'll click on these, and then it'll appear in this box. You just make sure not to press OK, because that'll complete the mate. You'll just keep left-clicking until you're done, then press OK. Yep. So now what I want to do is introduce the Quick Mate toolbar. So things, for example, like you have standard mates, where I want to say, you know what, I want to make this face and this edge here coincident. I would have to go up to mate. If you control select both of the entities, there's now a Quick Mate toolbar that it's only going to show you standard mates, but it's going to be coincident, tangent, concentric, things like that. And it's only going to be available when you control selected entities. And it's kind of like it's an easy way to create your standard mates without having to go into the mate menu. Okay, so we do that one more time. All you have to do is just control select, pre-select the items before what you want to do, control, and then select the other face, right? And what we'll do is we'll get this little menu to allow us to be coincident. Okay, so it'll move it over. So once again, that all is just streamlining the process so you don't have to go into the main menu. It's the same way. So you can see here, I can rotate this guy. I can also rotate this one as well. I mentioned planes. So for instance, if I want to make this plane here, which I have this one, I'm going to show that and make sure my planes are showing. And I'm going to see what plane I want to reference this off of. In this case, the front plane. So I'm going to make the front plane and make it coincident to the plane of the part itself. So it's going to line up correctly so it won't rotate. And at the same time, I can also just make it parallel here as well to press OK. Go ahead and hide in the rest of our planes. All right, you can see that I can no longer rotate. I can just set a specific distance for here. And then now what I want to do is I want to go ahead and left-click. I want to insert this component into here. So one of the ways I can do that is I can just simply control select both of them, add in a concentric mate using the quick mate toolbar. And then I also want to, for instance, select this face and I want to mate it up with the other side of that face. But you notice that I can't already select it, right? Obviously I can rotate it and select it. But if you're in a situation where you can't easily rotate to select another face, you can use what we call select other. So if you right click here, you're looking for this icon, okay? It's the select other icon. It's basically a yellow square, but it's a green square in the back, and it's trying to select that one in the back. So if you click on select other, what it does is it makes that face that you selected on initially transparent. And what's great is, say there's more faces in the way, like for example over here, you can keep right clicking. So you click on your right key on your mouse, and it'll keep making the faces transparent. So eventually you will end up with the face that you need. Okay. So you keep right clicking, notice I'm right clicking here, it disappears over here, and eventually I'll be left with that face that I need. Okay. So I'll left click, notice how it highlights on the other face, and I'll go ahead and control select that face and then make those coincident. So that'll be select other. It's also available outside in an assembly. You can also use it in parts as well. Okay. After we got our assembly all set up, I'm going to pop back over to my full level assembly, and then I'm going to identify the sub-assembly I want to place it in, which is this guy here. So I'm going to find that first, open this up. Then now, you'll notice it's the first assembly we worked with, the first sub-assembly. We'll insert this air filter we worked with. And I only want to focus on this guy, that air filter, and this plate. That's what I'm going to mate it to. So I'll go ahead and right click and go to isolate. Okay. Before I go into this, do you guys know of a way where, for instance, maybe you're starting to hide components because you want to see through them, right? Instead of making them transparent. You select certain components, you hide them, and the thing is, you probably, you might have kept track of exactly what's hidden and what's not, right? But the hard thing is there's sub-assemblies, then you kind of have to dive into each individual sub-assembly, right? So an easy way to select them is if you go to up top on your rebuild icon, to the left of it, and you pull the drop-down menu on your selection tools, there's a select hidden. So if you go to select hidden, what it's going to do is highlight on your feature tree all of the components that are hidden. Then you can right click, and then you can click show. What you'll see is you'll bring all the components back. Okay. So an easy way to select all your hidden components, you can do suppress as well, right? And it'll kind of dive into all your individual sub-assemblies. So now, once again, I want to focus on that air filter, this one, and this face. And I'm going to right click and go to isolate. It'll isolate just those components. Okay. I can use what we call Smartmates. And what Smartmates are pretty much, if I click on and hold down the Alt key, what I want to do is drag the entities I want to mate together. So for instance, I want to mate up this face with this one. So I hold down the Alt key, and I'm going to left click, and I'm going to drag it. Notice how it becomes transparent. And then I just hover over what I want to mate it to. You'll see how it tries to mate to that face or to this one, right? Depending on what I drag it over to. And I want to ultimately drag it over to this face. I'll let go. And then press OK. So that's another way I want you to do it. This was introduced before they did the quick mate toolbar. So, you might think it's redundant, but you can really do it in multiple different ways. I can add in a concentric relation doing the same thing. If I wanted to do, for instance, another quick mate, all I have to do is just hold down the Alt key and drag it over to this one, and you can see how it creates a concentric mate. So that's only using the Alt key, right? It'll rotate about that point. Now, the advantage of Smartmates is, we've done coincident, we've done concentric. You can actually do both of them at the same time. And that's what we call a peg and hole. So all I'm doing right now is just undoing all of that work that we had done. And what you can do now is I can say, you know what, I want this edge right here, this one, and I want to drag it to this edge. So I'm going to hold down the Alt key, I'm going to left click, and I'm going to drag over to that edge. Okay. And you notice the icon is a little different. It's pretty much a cylinder going to a cylinder. It's going to create a concentric and a coincident mate. So as I let go, I'm going to scroll down on my mate toolbar. And what I'm going to see is they've added both a concentric and a coincident mate. Okay, let me do that one more time. All I did was I selected the edge, held down the Alt key, and I'm dragging it over to that edge and letting go. I'm getting that icon, and it creates both a concentric and a coincident mate. Okay, concentric and coincident. To finish this up, I'm going to go ahead and select that face and this one. I'll make those concentric. And then I have my air filter on there. Exit out my isolate, go back to the assembly. Then now what I can do is I can focus on, for instance, my new mates. Okay, so this is where we introduce just the regular standard mates. If you've never seen them before, that's how we relate one component to another inside of an assembly. Now what I want to do is focus on the new mates. So here we have a front light assembly that I'm going to work with. In this one, we're going to introduce a slot mate, the profile center mate, as well as a width mate. And I want to first go ahead and select this face, and I'm going to make it coincident here. And then also, before they introduced a slot mate, there were some things where you had to do some workarounds if you wanted, for example, this to mate up with this slot for it to follow along there, especially if you have a pin going through the middle. So now what they introduced is under your mates, you have to go to mechanical mates, and you're going to go on the slot tool. So you click on the slot tool, and then you notice I selected the inside cylindrical surface, and then now all I need to do is select this slot surface. On the left, click this, press OK. You'll also notice that it allows you to center in the slot too. So then, for example, if I want to press OK, I can pivot about that point. I can also have it just be free. I can have it do a distance along a certain part, certain distance, or a percentage as well. Maybe I don't want it to be 50%. I want it to be a little bit more biased to one side. Or I can just set it to be free. So now I can freely move left and right, and it will be able to rotate as well. So now my goal is I want to get this light, and I want to add it concentrically over there. So I was planning to grab my magnifying glass, zoom in, and control select it, and make that concentric. And now what I want to do is use my width mate. Okay, so some people have never ever seen width mate before. It allows you to, for example, I want to be able to center this evenly between the U bracket. Okay, and some people have been able to do distance mates. Essentially, what I want to do is make the distance between this face and this one the same distance as this face and this one. Okay, so equal distance both sides. There's lots of different ways you can do it. You can do a symmetric mate. You can do a couple of distance mates as well. Then you can also do your width mate. So once again, width mate is not something new. You're going to find it under the advanced mate. And what you do is you select your width selections, which is this one and then this one. And then your tab selections will be this face and then this face. Okay, but notice now they've introduced more constraints, kind of like in the slot tool, where you can now freely move it from left to right. You see here, left. If I were to fix that slot, I can move it left and right. Dimension, percentage as well. Okay, if I'll go ahead and center this, it'll center it right in the middle. I want it to freely move it left and right. I can press OK. And then I wanted to fix this, for example, and then see exactly how this moves. You can see how it freely moves between left and right. So there was a question that says, what about the Analysis tab next to Mates? So I see Mates here, Analysis tab. See if you can clarify for me in the questions, and I'll kind of keep carrying on and see if I can get back to that one. Okay. So now what I want to do is rotate this guy, and you can see here how I can still freely rotate it between the components and the faces, right? And I wanted to get to a position where I can kind of at least constrain the range of motion here. I want to be able to go up and down. So I'm going to go ahead and set that first mate. I'm going to set it to be centered. And then now what I want to do is I want to add in a mate where I can say, you know what, I want to limit its range of movement. So I'm going to use the with mate again, so I can use it before between angled faces. So I'm going to go to my with mate. I'm going to select this face and then this one. And under my tab selections, I will select, I'm going to go ahead and make this free. I'm going to select this face and then this one here. Press OK. Oh, the question was, what's this analysis tab for, right? So it's going to be for your motion analysis. So any kind of, obviously you can see here the motion here that I'm doing. If you want to do motion analysis, then you can go ahead and click on this and then add motion analysis properties. So once you have it there, I can go ahead and now freely move it between up and down. So what this allows me to do is freely change the amount of, kind of define its degrees of where I want to be able to rotate. Obviously, if I wanted to have more degrees of freedom, I can definitely do that, right? If I just want to be able to say, okay, you know, when this face up there is parallel with the top one, it's going to limit its range of movement. Kind of like an angled, limit angle mate, okay? That you can also do with your with mate as well. So now what I want to do is I want to go ahead and go into my assembly again. And I want to be able to go into my assembly and say, okay, which do I want it on? And I want it on this back one. I'm going to go and open up the assembly that this is associated with. And then now I wanted to attach that same front light and place it in there. Now, so now my next question is I want to be able to select this face and this one. And I essentially want to mate up the centers, right? At the center of that rectangular profile with that profile I have selected. How do I do that? Right. Ideally, I'd have a plane right in the middle. So I can just mate up the two planes, you know, horizontally and vertically. Or I can do a couple with mates, right? Two with mates as well. But then I'd also have to verify how it's going to rotate, because even though it's centered right in the middle, it can still rotate freely, right? So what they've introduced is something called the profile center mate, and it kind of explains exactly as it sounds. You go to your advanced mates. There's a profile center mate. You click on profile. Click on this profile and then click on this one. What it'll do is it will mate up the centers together. Okay. And then this will allow you, for example, in this case, the light doesn't do me much good for pointing up. I'm going to go ahead and rotate this in a clockwise direction. Okay. You'll notice that if it's reversed, the mate alignment and where it's going into the tire, it's not going to help us much. So I'm going to go ahead and reverse it, the mate alignment. Okay. And rotate it as needed. Press OK. And press OK. Okay. And then I can do the same thing on the other side as well to add in that front light. So that's going to be introducing our new mates. Okay. And once again, if you guys have any questions, please let me know. But now what I want to do is pop in. I'm going to go ahead on the right-hand side. You might have noticed my task pane is gone. So I'll turn that back on. So I'll go to View. I'm just going to bring back my task pane. And I'm going to bring in our Toolbox components. Okay. So Toolbox is going to be available. Oh, also, these are best practices for mates. Okay. We've covered it, the first one already. Pretty much mate all components to one or two fixed components. Have some kind of reference, right, as opposed to a loop of them. Minimize top-level mates. We'll cover assembly expert. It'll show you exactly how to identify how many are in there. And also fix mate problems as they occur. Okay. And then avoid excessive mates. Okay. And on here, I want to talk about Toolbox Components. This is SOLIDWORKS Professional as well as SOLIDWORKS Premium. It's going to be library standard components, bearings, bolts, screws, retaining rings, nuts, different standards as well. Okay. So if you guys have used it before, great. You guys know kind of its capabilities, definitely. But if you haven't, right, I have a situation where I want to add in just some hex bolts on here, okay? And I want to identify this subassembly and this one as well, and I want to isolate the two. And then now I want to add in my toolbox. So that's going to be under your add-ins. It's a professional and premium add-in. So I'm going to activate on my toolbox browser. And I'll go to toolbox, and I'm going to activate it. So now I'm going to identify exactly, what kind of bolt that I'm looking for, in this case a hex bolt. And the process is really simple. This has hole wizard holes, so it has standards already, predefined cross-section. And because these are based off those standards, what it's going to try to do is resize to those, right? And in this case, I do have the M12 that does match this size. But if you find out, hey, you know what, maybe you've done it a regular extruded cut that's not defined to a certain size, just the one that you wanted it to be, then you can go ahead and choose the correct size for it. Then afterwards, all you'd have to do is then, if you have subsequent ones that are the same, you can just left click and place them in there. They use mate references to mate them up. Okay, so that's one way that you can use Toolbox Components. I also want to introduce the fact that you can add in washers, nuts as well. So for instance, if I want to bring in the hex bolt again over on this side, I'm just going to do one. And then afterwards, I'm going to add in a washer on one end. So I'm going to rotate on this side. I'm going to add in a washer. And then I'm going to add in a nut. And the reason I wanted to just do one side is I want to be able to then use something called copy with mates, right? So another very useful assembly tool, which allow me to copy not only my components, say if I do multiple instances, but then also if I have mates that are obviously going to populate as well. So you can see here, I have this hex bolt, the washer, and the nut. And I'm going to, under Insert Components, there's something called Copy with Mates. It literally copies the component first, which ones you want to do, which are these three. And then afterwards, I want to select the references for the new mates. Okay. You can see over here, it's going to choose the mates that have what mates are available on this guy. And then I want to see, hey, you know what? I can actually copy this. So I can repeat this one. I don't have to do it over again. And over here, I can do the same thing on that side for that washer. So I'll go and repeat there. So all I have to do really is just left click on the holes. That'll make it concentric. It'll add in the washer and the nut. And I can do the same thing over here. And literally, I can just repeat the set. The hex bolt, the washer, and then that nut. And I'll just go ahead and do this last one to complete it. Okay, so it brings in that subset of components really, and you copy, once again, the components as well as the mates. So have them in there. You can use them outside of Toolbox Components, so you don't have to worry about if you are running standard, copy with mates are still going to be there for you. I just kind of like bundling the two together. Go ahead, exit isolate, and I'm going to pop back into my options. Just a little bit more about Hole Wizard and Toolbox. So if I go to configure, this is where I'm going to be able to configure my toolbox. Things like, for example, there's things called smart fasteners, where if I select the Hole Wizard hole, it's going to see if it can populate a specific toolbox component in there for you automatically. Here as well, you're able to reassign it. Say it's bringing in the wrong one, right? You can then choose the correct one that it should be bringing in. Here is your actual hardware itself, right? And then you can see all the individual configurations for the specific size that you're looking for. And then here it allows you to define your user settings or configurations, permissions, and so forth. Okay, so this is where you're going to be able to configure your toolbox. The next step, what I want to do is I want to go ahead and talk about large assembly performance. Okay, so really, what is a large assembly? It's essentially a lot of components. It can vary from a couple hundred to a couple thousand, and they have parametric relationships to one another, and large number of mates, top-level mates within the assembly, sub-assemblies, and just complex geometry. And why that's important to us is we find that some people, right, it taxes their computer resources and hurts their productivity. And when we mean productivity, when we mean performance, what we're usually talking about is just their speed, right? What it takes, how long it takes to open, close, rotate something, save it, rebuild it, just do some mating techniques, right? And it just affects their system. So unfortunately, there's no magic bullet. There's no one button you click on it and large assembly just runs better, right? Unfortunately. But what influences performance, the next step, is three things: hardware, software settings, and modeling practice. And what we take a look first of all is the hardware. I'm running an HP EliteBook, Intel i7 2.4 gigahertz, and 8 gigs of RAM and a Quadro card. And another one that's not listed here, I don't have it. It's an SSD that also affects performance as well. So you can see here the three things that affect it is CPU, amount of RAM that you have, as well as the graphics card. Just making sure you have the approved certified graphics cards for that manufacturer. In this case, the Quadros for NVIDIA, or the FirePro for ATI. And just making sure you have enough RAM and a strong enough CPU. So in addition to that, besides hardware, right, what software settings affect large assembly performance? And first thing is just your add-ins. I talked about it where we add in Toolbox browser. Only have the ones that you're going to be using for that session turned on, right? Just general practices. If you don't need it, you don't have to have it turned on. If you're not using SircuitWorks, there's no need to make it sure it's active, right? It'll just start slowing down and bogging down your system. And there's also things like, for example, performance. Now, this is where you're talking about large assembly performance, where there's things you're thinking about, you know what, things are just too slow. It's taking me forever to do a simple task, right? Now it's more about compromises. And when we're talking about performance, there's something called verification on rebuild, and it says enabled advanced body checking. And when you have this on, when you do a rebuild, it checks faces against all the other faces inside that model, inside the assembly. Okay? So in that case, the alternative is if you have it off and you do a rebuild, it checks the faces only against the surrounding ones. So in that case, if you are doing your rebuild and it takes too long, you want to go ahead and uncheck it, do a rebuild, and then that possibly faster. But of course, our recommendation is to check it on, you know, every so often, just to make sure your model itself is rebuilding fully. Okay, so recommendation: if you're having large assembly performance issues, uncheck it when you're doing your rebuilds, and then just check it on periodically to make sure everything's okay. There's also another one called automatically load components lightweight. I actually mentioned a little bit yesterday, but for anything that falls out of the large assembly threshold, for instance, if large assembly mode turns on after 100 components, right, this one covers it for the amount that's under. So for example, you have 99 or 50 components in an assembly. If you have that checked on, it'll load those components lightweight as well. In your system options, we have large assembly mode, which I was talking about that threshold. Right here I have in the image set to be 100. So that means anything over 100 components, auto recover info is not going to save, edges will not be displayed in shaded mode, things like that, as well as large design review. And if you have large design review checked on, it will turn on automatically when you have more than, you can specify the number, how many components there are. And that will, I'll cover large design review, but it's a great tool, you know, as a manager or just as a top level engineer. I just want to see the progress of the assembly, you know, create some quick snapshots, see how everything's coming together, maybe selectively open certain components. There's also image quality. So if you've ever seen where you zoomed into something like on a part or an assembly, and it looks more like a hexagon versus an actual circle, right? What's happening is, it's treating it, it's loading it faster, right? That's why it's still a circle. You don't have to worry about if there's going to actually be edges on there, right, as a hexagon. But it's just going to load faster on the top one versus the bottom one. And, as you're going from low to high, you're just causing more graphics triangles to be calculated. I'll talk about that when we do assembly visualization. But essentially, it'll cause, obviously, a significant slowdown in your performance, and it'll also increase your file size as well. Okay. Other ones that are important, backup and recover. The larger that you have this number, the better for performance. If you have it start down low, like for example, every 1 minute, then it's going to check in every 1 minute. And then also something called the view transition, right? So as I'm going in between my views, as you can see here, if I click a spacebar and go top view, right view, it goes pretty instantly, right? So if you prefer in seeing some kind of transition, you go to your view and then click on, for example, slow, and you're going to see it animate between the two. So it's going to transition there. So maybe you're looking for, hey, as I'm going from one view to another, I want to see exactly how it looks, right, with respect to the other views. You can do that. But then, if you're experiencing things are just going way too slow, or you need to just get there quicker, then you have the ability to make that faster, or just turn it off altogether. Okay, so instantly go to the view that you're looking for. And lastly, there's underperformance. There's a level of detail. So as I bring it more to the left, right, it's going to try to maintain 1 frame per second. So you'll find that, when you rotate it, this will be a little bit slower, but it's going to keep its detail. But sometimes you'll find that, it's just going too slow. Then things will happen like this, where you're trying to rotate. It'll treat it as blocks, but you're going to find that this rotates much faster. And what it's trying to do is maintain at least 20 frames per second, right? And usually it'll simplify it. You'll get these boxes. But once you let go of stopping to rotate, the detail will return back to how the image is on the left-hand side. Okay. So in short, what it means is if you have it more to the left, your assembly is going to rotate and just move slower because it's trying to maintain a level of detail. But if you go more to the right, it's just going to be faster. The level of detail, once you rotate it, it's going to look like these boxes. But then once you stop rotating, it's going to return back to its level of detail. Okay. And you can see here how it's locked to faster when you have large assembly mode on. Things that you can use to assess your model performance are Assembly Expert, Assembly Visualization, and Feature Statistics. So just a quick primer on Assembly Expert, right? If you go here, I'll go to my bolter. I can go ahead and go to my Evaluate tab. And what I'll do is take a look at Assembly Expert. And what Assembly Expert allows me to do, it gives me some things to look out for. Or I can say, you know what, in this assembly, first thing it says, files for all components have been updated to the latest version. Okay, so what that'll mean is if you have versions of files that are in 2008, 2010, 2012, just different versions, it's just going to load slower, right, than it wouldn't be if everything's at the same latest version. So that gives you a check for that. Also, how many resolve components are on there. If there's a large assembly and it talks about large assembly mode is on or off, it's a check mark for on because it will help improve performance. How many mates are evaluated when the assembly is rebuilt? How many of them have in-context relationships? You can see how this has an X, right? If there's in-context relationships, just by how it's designed, it will resolve slower because it has to check, okay, it's dependent on something else versus being independent. Also, total number of components. Here I have about 5,000. That's why I mentioned in the beginning. That's how I know how many components in the assembly. I didn't have to guess. I didn't have to count every single one. It tells you also the maximum number of depth, the levels of sub-assemblies and so forth that's inside my assembly, a top level. How many resolved? Let's talk about lightweight components. How many are suppressed? How many are hidden? Things like virtual components. Maybe you say we can't have any virtual components. This will allow you to see if you have any in there. And also top-level mates. Recommendations to have the lower number of top-level mates allows it to rebuild and process, right? And also, it mentions it here, other diagnostic tools that are available, like SOLIDWORKS RX. What this allows you to do is, say your system is, you're in 16 gigs, faster CPU than I am, great graphics card, and you're running, only like a 50 component assembly, and it's running slower than mine is right now with 5,000, right? There's something wrong. So what you can use is use the SOLIDWORKS RX. It's a diagnostic tool in SOLIDWORKS Tools. You just go ahead and go to your SOLIDWORKS Tools in your version. And what you'll do is click on SOLIDWORKS RX, and then it'll grab diagnostic information from your computer, and you can forward it to our support if you have support with us, or then we'll send it over to SOLIDWORKS to kind of dive deeper and figure out what's going on. Okay. Also, it mentions feature statistics. That's what we'll cover in the next part. It'll tell you exactly which features take the longest time to rebuild. So we'll take a look at that too. So we talked about assembly visualization as a second one. And assembly visualization gives you a chance to visualize exactly what's going on in the model, right, visually. So for instance, you can sort by really a lot of different kind of variables, things like what has the most mass inside the assembly, right? And you can apply colors to it. And what this will allow you to do is just take a look at the model in a different perspective. It'll color the model. You can also sort by graphics triangles. You can also sort by things that are going to matter most to you, right? Like for example here, I can see exactly what has the most mass. I can highlight it from there. It'll give me different colors. I can turn on a slider, things like that. And then now if I want to say, you know what, I want to figure out, okay, what is taking the most time to rebuild? Because I mentioned before that how your part is going to be built is also going to affect how your model is going to. You can see here how the rebuild time, what takes the most, is this drill assembly. So let's kind of narrow it down. Let's go from the assembly down to the sub-assembly. So we're taking that drill assembly. It takes a long time to rebuild. Let's find out why, right? So let's run assembly visualization again. I can sort by rebuild times, or I can also sort by graphics triangles, right? So that's according to your level of detail that's inside of your part. So we mentioned before where level of detail does impact your assembly performance. You can see here over here on the left-hand side, it's 4.5 seconds. Over here, it's 0.75. Much simplified version. Things like, for example, you're getting a vendor part, and you really don't need all that information, right? You can go ahead and simplify it down, especially if you don't need to mate to it, right? Especially if you just need to just purchase that part, you just need to have it in the assembly, right? You don't need all that level of detail. We talked about graphics triangles, where on the left-hand side, that's going to be load much faster than the one on the right. You can see the detail is almost like at least 5 times as much on the right than it is on the left. So where we're talking about level of detail, use decals if you can, combine fillets of equal sizes. And the last one is hard to apply, but it's essentially if you can use extrudes and revolves versus lofts and sweeps, we find that those rebuild times much faster. Now, going back to here, right, we have this part that we say, okay, we now know that that one has the most graphics triangles. And now I want to figure out, okay, why is this one taking the longest time to rebuild, right? So I'm going to unfreeze this. And if you've ever tried to figure out, okay, we're going from assembly down to sub-assemblies, now into the actual part itself. If I go to my evaluate tool, there's a statistics. So if I click on this, I can then see, now I'm going down from part level down to the feature level. What exactly is taking the most time to rebuild, and what's taking the largest percentage? In this case, the combine is, right? Then I can figure out, okay, is there a way for me to omit or suppress that component, replace it with another one, right? And then go from there. So you can do that all the way going from top level, run assembly visualization. You can see which has the most rebuild time, what's the most mass, and so forth. It allows you to visualize the assembly itself, and then also kind of go down all the way from part level down to the feature level. Okay, and then also tell you your rebuild time, how many features are in here, etc. In addition to that, we also have lightweight components where you're loading certain components lightweight. Someone had mentioned yesterday, you know what, I don't want my components loading lightweight, and the reason for that is it doesn't load in your feature data, okay? So it loads less model data into the memory, but you're still able to add or remove mates, select certain edges and faces. You can still do the mask properties, exploited views, collision detection, things like that in the assembly. But you'll notice what happens is you get something like this, or if I pop back over to my drill assembly, I can turn off visualization, and I can collapse all this, Shift-C. For example, this pin right now has about 10 or so features in the feature tree. If I right-click and then expand this out, I'm looking for set to lightweight. There's a little blue feather by it. So if I click on that, you'll notice now it's reduced it down. It doesn't delete the features. It just loads it lightweight, doesn't load it into memory, right? But I can still select it if I needed to, right? I can identify exactly where it is in the model. I can still mate to it. I can select the faces and everything like that. It's just going to load much faster. So that's why when in large assembly mode, it'll load your components lightweight as well. And how you would reverse it is you would then just fully resolve it. So large assembly mode takes into account the lightweight components, but also a collection of system settings as well. So things like, for example, dynamic highlighting, shadows in shaded mode, real view graphics, things like that will turn it off. So some people have questions about, you know what, I have a large assembly and I'm not getting, for example, real view graphics, right? Is it because I don't have a graphics card? I'm not seeing the shadows in shaded mode, or if I hover over something, it doesn't dynamically highlight, or you notice here, I can't even select my edges until I actually select it myself. That's all because of large assembly mode. So if you go to Tools, you'll scroll down all the way until you find large assembly mode. And here you can see I have it active. Uncheck that. And you can see how it now brings in things like I can highlight, the edges will now select. And if I want to go one step further, I can see I have real view graphics as well as shadows and shaded mode, right? So if those are important for me, I can bring those back, right? Deactivate large assembly mode. But what large assembly mode does, once again, is compromise, where it's saying, hey, you know what, I want to be able to kind of reduce the performance things that I don't need, right? And I just want to focus on what I do in terms of mating and things like that. So just a few finishing remarks, same exact things that we talked about before: minimizing top-level mates, image quality, making sure you have that, utilizing configuration display states. You notice I have that entire resin and bolter, but if I only want to work on certain subcomponents, right, in that final assembly, but I still have to be inside that assembly, I can create what we call configurations, allow you to simplify it, but then also just focus on certain sub-assemblies. It'll make it faster to open than instead of the entire fully resolved one. And then you have large design review, where, let me go ahead and close down my model. And what large design review is going to allow you to do is kind of take a top-level view, and it's going to open much, much faster. So say, for example, you need to open it up as a manager and then figure out, okay, what exactly is happening. Let me just go ahead and quickly close all of this down. Don't worry, it's not crashing, right? It's just closing this down. What I want to be able to show you is this. Exit out of here, and then pop over to my SOLIDWORKS. And large design review, it's going to be another way for you to open up your assembly. I'm going to File, Open, select that assembly, and under large design review, open this up. And over here, this is what it's going to be able to do. You're going to be able to navigate your feature tree, selectively open components, right? Create cross sections. It'll tell you, and then I'll go and open this up. So generally, it takes my system about three minutes to about 4 minutes to open it up. But with large design review, it takes about 1 minute. And the reason it does is because it's not loading up everything, right? You're going to be able to review the assembly, things like be able to measure, do section views, hide and isolate components, take a look at the feature tree, and then from there figure out, okay, I only need to open up, component number 1 and 5. Then you can selectively open that. That's going to be much faster than if you have to open up everything, right? So you can see here within probably less than a minute, it opened up the assembly. And right now, up top, you can see all the capabilities. You can do walkthroughs. You can take measurements, right? This is going to calculate the approximate distance. If you want to get the exact one, maybe it's a very important dimension, you want to make sure you resolve it before you take, just to compare the measurements. You can do section views, take snapshots. And also another great thing is, for example, here, maybe if you just need to focus on this component here, right? But then you have to open up the entire subassembly or the entire assembly to get to it. You can go ahead and go selectively open and then choose the components you want to open, right? The subassembly or so forth. And one thing, and that's going to load much faster than if you had to load up everything else, right? And you can see how literally that opens up the assembly. So you can see how quickly that was, right? And I can just focus on this one, do what I need to do, save it, and then get back out, right? And that's going to be much faster than if I had to open up my entire one, isolate, and then add in my mates. And the last part I wanted to cover is file references, okay? So very important with your assemblies, if you guys have ever wondered before, how, for example, do I check what has references to what, right? So the best way to check is to go to File, Find References. You're going to see that this assembly right here, the bolter that I have, these are all the components that are associated with it, and also the location where they are, in this case, in this specific folder that I have, right? So how you want to find those are the references to it. And I want to show you the incorrect way on which to rename your files. So if you go here to your new bolter, and I'm going to open up my front light that I have, the one that we worked with a while back as an assembly. And it's going to be this one here, right? And this U bracket. All I'm going to do is right-click and go to rename, okay? If you guys have ever done this before, most likely you know that this is not the way you want to do it, okay? Because of those same references. What it's doing is it's saying, hey, that assembly is looking to this folder for that name. So when I try to open up that front light, it's going to say, hey, where is that one, right? So you can browse to it, or you can suppress the component. If you suppress it, it's not going to be able to open it, right? Because it doesn't know where that, it doesn't know it's been renamed. If you're the one that renamed it, you can always unsuppress and browse for it and find it, okay? So the correct way in which you want to do that is if we go and rename this back, you want to right-click, and this utilizes SOLIDWORKS Explorer, okay? And you're able to now rename it. So when you do it this way, the difference is it's also looking to its references. So it's going to update where it's being used, okay? So what it's going to do is search through your specific locations, and it's going to look for where it's being used. And then afterwards, it's going to then update its references, okay? So if it's looking to an assembly, if it has a drawing that's associated with, it'll go ahead and update that, okay? And then we can then rename it to, for example, U bracket. Now, as it's kind of searching along, if you decided, you know what, I need to send this assembly to somebody else and they don't have all the components already, right? Or you wanted to create a copy of the assembly that you're working with, right, and then do some investigation, but you don't want to infect the original one, right? Most likely you guys know, but if you don't, there's a way where you can do that. It's called a file pack and go. And what this will do is bring in all the references that are associated with the subassembly or this top-level assembly, and then it's going to go ahead and zip it up into a folder or into a zip file. Okay? So you can see here, back to our renamed document, it finds that, hey, it's looking at this front light. If I go ahead and click OK now, it's going to then reference the U bracket. Okay? So that's the most important part. It's update where it's being used. So we had someone, yes, so correct. this is all going, using SOLIDWORKS Explorer is all assuming that you do not have a data file management system. So when I mentioned do not use SOLIDWORKS Explorer if you're using EPDM, right? Unfortunately, I'm not aware of how EPDM controls it, but I do know that they control it. So if you are using a PDM system, then use that to reference and rename your files, things like EPDM or Workgroup PDM. Okay, so use that file system to rename your files because those maintain certain references. So this is all assuming that if you do not have a PDM system. Okay, so thank you for clarifying. So you can see here your pack and go is going to list all your files, all your references to that assembly. You can then save it to a specific location, or you can save it to a zip file. This will easily zip it over. Maybe you need to send it to somebody or send it to us, right? It can include all those files in there, so I don't have to hunt and pick and choose exactly where those are, right? And it'll be in a different location. So you literally have 2 sets of these components without having to pick and choose in the individual folders where everything is. Okay, that is going back to your references. So to kind of cover what we went over today, I know we went a little bit over time. So talk about maining techniques, toolbox components, large assembly performance, as well as file references. And I just want to kind of talk about, in terms of value. So it's always finding out other things that are most important to you guys, right? So this, for example, this night school, covering the wide spectrum of it. Hopefully you got some little quick tidbits, just a reminder of something you've never seen before or you have seen before. And also the Hawkridge YouTube channel, very useful, quick videos that you can kind of search and figure out, okay, if there's a new version and you want to upgrade and you want to figure out what exactly is new in there before you actually do, you can search on there and then you can figure out, for example, see what's new in 2015, 2016, instead of reading like the 100 or 1,000 page PDF, right? You can see visually happens and then you can figure out, okay, if I wanted to do it now, I can just follow these steps. There's also the blog as well. That's all on our hawkridgesys.com website. All right, guys, so thank you so much for tuning in. I'm glad you guys got a lot out of it. And if you guys have any questions, feel free to let us know. Okay, have a great day.